Hello, I am Gabriela and the co-author of this project is Maribel. We are so happy to present our project that title is Experimental Study of the Influence of Temperature on Pasteurization of Pêra in Natura Orange Juice. Citrus industry is an extremely important sector for Brazil, as the country is responsible for 34% of the fruits and 56% of the juice produced in the world. One method we can use to treat food is heat treatment, and it's used to preserve food such as orange juice and increase its shelf life. However, we don't know so much about the temperature and speed profiles during heat treatment of liquid food in commercial packaging. Pasteurization is a process we can use in foods when we want to destroy pathogenic microorganisms and the natural low heat resistance enzymes present in foods. Pasteurization consists of heating the food to a certain temperature and time, and subsequently cooling it to a temperature lower than the previous one. The literature shows us three types of pasteurizations, but to the orange juices we use HTST, high temperature and short time. Orange juices are an excellent source of ascorbic acid, and we normally call ascorbic acid as vitamin C. And to avoid vitamin C degradation and reduce loss, we can use fast heating and low exposure to air when we are preparing the juice. In the literature, we can find other studies about heat transfer during pasteurization and about food cooling, and you can check some of them below. So this work aims to determine the vitamin C content using iodometric method and the convective heat transfer coefficient using the method of dimensionless numbers and the experimental method in the pasteurization of orange juice. The juice was prepared and placed in a 200 ml cylindrical glass container sealed. To control the temperature during the experiment, thermometers were used, and to control the time, a stopwatch was used. The vitamin C content was analyzed before and after the pasteurization using iodometric method. The temperature was recorded every 2 minutes in all the experiment. The water bath was already heated to 80 degrees Celsius when the juice was placed in the bath. When the central region of the container with orange juice reached 74 degrees Celsius, heating was stopped. Then the cooling was performed, where the sample was placed inside a stainless steel pan with ice. When the center of the juice container reached 6 degrees Celsius, cooling was stopped and the bath was cooled to 0 degrees Celsius. Now the results. In this study, pasteurization lasted 92 minutes, and we can observe in the figure that the two regions present practically the same temperature variation, and we can find this trend in the literature, the same trend. We can observe here that the convective heat transfer coefficient is higher in the region near the wall, and there is a sharp drop in the convective coefficient curve in the wall region. And this is due to the fact that the temperature is very high at this moment, as it is the period when cooling starts, so the value is lower. As time passes and temperature decreases, the central region tends to equilibrium and the coefficient becomes more constant. About vitamin C content, it remained constant before and after pasteurization. We could observe that both the region, the center one and the wall one, have similar temperature variations which are in agreement with the profiles we can find in the literature. The convective heat transfer coefficient is higher in the wall region and tends to equilibrium over time. It was observed that the pasteurization didn't cause ascorbic acid degradation since the heating step was fast in the heat treatment. So, studying the thermal behavior in the cooling of orange juice is extremely important to guarantee its quality. Here are the references. Thank you so much for the attention.